Hello everyone. In this lesson, I would like to go over a few more examples of definite integral of more complex functions, and we have to apply the fundamental theorem of calculus to calculate the area under the curve specified at the upper limit and the lower limit. So example 1, the integral from 0 to 3 of this function, and I kind of sketch a graph for everyone here so that we can have an idea of what type of area that we are dealing with. So from 0 to 3 for this function, so I will have to calculate roughly this area underneath this curve. Okay, so let me highlight this curve for everyone. Alright, okay, so I will write the area will be equal to the integral from 0 to 3. So don't forget this is the 0, this is the value of 3, of 1 plus 3x squared, all of it raised to the exponent 1/3. So I might as well do this here and prepare myself before I apply the integral for function raised to a power in this case. Okay, so you have a function raised to a power here, and here's your differential factors. So I will have to match this part. So I'm going to let u equal to 1 plus 3x squared. So letting u is equal to 1 plus 3x squared, I can differentiate this, and I should have it equal to 6x. Okay, and I need to achieve x times dx on the right hand side of this equation, so I will write du over 6 equal to x times dx. So now I've already achieved my purpose, and we put this one in this bubble because we already complete that. So now what I will do next is the area will equal to 0 to 3, right? And then I will write it as u raised to the exponent 1/3 multiplied by du divided by 6. So I'm going to write the 1 over 6 across the integral side. So I have 0 to 3 u to the 1/3 times du. So I will add 1 to the exponent in this case. So 1/3 plus 1 will give me the answer as 4/3. So what I have next is a, which is equal to 1 over 6, and I'm going to multiply by the reciprocal of 4/3. So now u raised to the exponent 4/3 divided by 4/3 means I multiply by 3 over 4. And what I would ask you to do in this case is you are going to plus c, because you haven't applied the fundamental theorem yet. Now this is our next step. Okay, so I want to emphasize to everyone that the notation is actually quite important. I will simplify this as well. So I should have this cancel with that. So the fraction in front of this should be 1 over 8. Now I'm going to replace u by the function in terms of x. So 1 plus 3x squared, all of it raised to exponent 4/3. Now you're going to apply the fundamental theorem. So you draw a line and you indicate the lower limit of 0 and the upper limit of 3. So in this case, I want to remind everyone that you're going to take f of 3, subtract the f of 0, and be very careful because this f of 0 here may not be equal to 0. So we still have to perform all the steps. Okay, so I know for sure that it is not equal to 0 because we have a 1 in this case. So let's apply the fundamental theorem. So a is equal to, I will put 1 over 8, and I will multiply by everything that I evaluate inside this bracket. So I will have 1 plus 3 times 3, because the upper limit is 3, a square. This is 3 square, right? And I will raise all of this to the exponent 4/3. So this is my f of 3 in this case, right? So f of 3 we double check that. Where the x is, we replace that by the number 3. And then I will subtract this with the f of 0. So I have 1 plus 3 times 0. This is 0 squared, all of it raised to the exponent 4/3 in this case, and close the bracket. So this should be f of 0. And if I evaluate this part here, I should have it equal to 3 times 3 squared is 9. 9 times 3 is 27. 27 plus 1 is 28 raised to exponent 4/3. And what I have here is 0 squared is 0. 0 times 3 is 0. 0 plus 1 is 1, so you should have to subtract 1 raised to exponent 4/3, and 1 raised to exponent 4/3 is just 1. Raise is 1 is a magic number, and if you raise anything to the raising 1 to any power is still equal to 1. So I got 1/8 multiplied by 28 4/3, subtract 1. You can use your calculator, and if you use your calculator, perform the operations accordingly. So raise this to exponent 4/3 first, take 1 away from the result and divide it by 8. The answer should be 10.503 as a decimal notation. Alright, I should put here unit square, okay, because we are calculating the area under this curve. So let's move on to the next example. Okay, so my next example, I am identifying my upper and lower limit at -1 and 0. So -1 here and 0 is right here. So now you see it's just a straight line, more than a straight line. So if it is a line like this, should the area become 0? Okay, so I can tell you that the area is actually equal to 0. And we apply Fundamental Theorem of Calculus. We do the calculation, and then we will prove that this area is actually equal to 0. Okay, so I will make a note here. A is equal to 0 as shown on the graph. But we will prove it, okay? By integrating. Alright, so I will write A equal to -1 to 0 of 1 minus 2x to the 4, all of it to the exponent 3, multiplied by x to the exponent 3 dx. Alright, so this part is the one that I need to match. So I will let u equal to 1 minus 2x to the 4. So du over dx will give me -8 x to the exponent 3. So I will divide both sides by -8, multiply by dx over to the side of the equation. So now I have this. Alright, okay. So now I can replace the integrand by du. So I will have the integral from -1 to 0. This is u raised to exponent 3, and I will multiply that with du divided by -8. I can go ahead and bring the 1 over -8 across integral sign. I should have this back inside the brackets. So then I will have -1 over 8 u raised to exponent 4, right? And then here's you multiply by 1 over 4 plus c. So I should have 1 over 32. And at this time I will replace u by the function of x. So I have 1 minus 2 times x to the exponent 4, all of it raised to exponent 4, and I will evaluate that at the value of -1 to 0. Okay, so I would like everyone to analyze and remember that you are going to calculate f of 0, subtract f of -1, because you are going to take the upper limit, the integral at the upper limit, subtract the one at the lower limit. Okay, and I pour the -1 over 32 at the front, and I calculated at the end. Okay, so now area equal to -1 over 32. So right here I should have 1 subtract 2 times 0, and 0 to the exponent 4. All of this is actually raised to exponent 4. Subtract 1 minus 2 times -1 raised to exponent 4, and all of this raised to exponent 4, close the bracket. Right here, this should be my f of 0. Right here should be my f of -1. So where the x is, okay, so here's the x. I replace it with the upper limit of 0, and I replace that with the lower limit of -1. Okay, so we have -1 over 32. So this is why I have a 0 to the exponent 4 is equal to 0. 0 times 1 times 2 is I'm sorry, I just got distracted for a second because I just heard a noise outside my windows, but I think it's just a bird. So 0 raised to exponent 4 is 0, and 0 times 2 is 0 as well. So I have 1 minus 0, so I should have 1 in this case, right? So 1 raised to exponent 4. So now we have to be very careful on our next one. So I will have this part here, -1 raised to exponent 4 will give it a positive 1, because you are raising a negative number to a positive exponent on an even exponent in this case. So negative become a positive. So 1 times -2 could give you -2. 1 subtract -2 will give you a -1, right? So 1 subtract -2 will give you -1. But don't forget, this -1 will have to be raised to this exponent 4. Okay, so I will have -1 raised to exponent 4 in this case. Okay, so so this will be 1. And if you have -1 raised to exponent 4, what you have is you are having a positive 1. So there will be 1 minus 1. So -1 over 32 times 0. So the area is actually equal to 0. Okay? Very good. Okay. So it's proven that it's just a straight line, so the area should be equal to 0. We apply integration, and using Fundamental Theorem of Calculus, we also proved that this area is equal to 0. Okay, so I want to remind everyone this become a positive 1. Okay, so 1 minus a positive 1, it means 1 minus 1, it become a 0. Excuse me. Alright, so let's continue on with our next example. Okay, so in this function, I would like to calculate the area under the curve from 1 to 3. So I will go from 1 to 3. 1, 2, 3. So then my area should be here somewhere. Okay, and the most important part is you are checking if your function is continuous, and we sketch the graph, and it definitely continuous in this case. Alright, okay, so the area is equal to 1 to 3. Excuse me, I'm sorry. So I will have I just happen to get a sip of water. So I have x squared minus 3x plus 7. I will raise it to the numerators and convert my exponent into a negative 2. Okay, and I will write this together. 4x minus 6 dx. Okay, so I'm going to let u equal to x squared minus 3x plus 7. So du over dx will be equal to 2x minus 3. Okay, but I need to have 4x minus 6 times dx. So what I will do is I will multiply this over to the other side of the equation. And I will multiply both sides by 2. Okay, so 2 du. So I distribute this. I should have 4x minus 6 dx. Now I achieve my purpose of making sure that the right hand side of this differential equation is equal to what I need to replace for the u. So now you see this and this is actually equal to each other. So basically my integral will be 1, 2, 3. So this should be a 3 there. So 3u to the negative 2 times 2 of du. Right. Okay, so I will bring the 2 across the integral sign. So 2, 1, 3, u to the negative 2 du. Okay, so the next step is to take negative 2 at 1. So that will be negative 1. So I will have 2. Okay, so I have to divide it by negative 1 in this case. So this will be u negative 1 plus c. So this will make it a negative 2. So I will have negative 2 times u to the negative 1 plus c. So I would like to write my equation like this. Negative 2 over u plus c. Okay, so I'm going to replace the u by the function in terms of x, and then I will apply the fundamental theorem. So the area will be equal to negative 2 over x squared minus 3x plus 7. And I want to evaluate this from 1 to 3. Okay, so I make sure that I write it like this. Okay, so I will evaluate f of 3 minus f of 1 in this case. So the area will be equal to minus 2. And inside the bracket, what you have is you have 1 over 3 squared minus 3 times 3 plus 7. So this is your f of 3 here. And then this is called the brackets as your f of 3. And I'm going to subtract that with my f of 1, which is 1 over 1 squared. X squared will be 1 squared minus 3 times 1 plus 7. And close the bracket. So this will be my f of 1. Okay, so we double check that where the x is, we will replace it with the upper values and also the lower value, the upper limit and the lower limit. So the rest of the stuff is just the algebra. Okay, so perform the operations. So I have here as 3 squared is 9 minus 9. So 9 minus 9 is 0. I have 7 left, so it's 1 over 7. And I subtract this with 1. 1 minus 3 is minus 2 plus 7 is 5. So I should have 1 over 5. So A will be equal to negative 2 times 5 over 35. Subtract 7 over 35. So I should have negative 2 times the negative 2 over 35. Okay, so my final answer should be positive 4 over 35, a unit square. Okay, so now you can see that finding the area under the curve, you should end up with the positive values. So if it's the negative values, um, I think we may have to take a look at our algebra and double check our work. Okay, because you shouldn't end up with the area as a negative, even though your area may fall into the negative part of the x-axis. However, the area should turn out to be a positive value. So I can pause and double check a bit. So if you want to express your answer here as the decimal, it should be equal to 0.11429. Okay, as a decimal notation. Alright, thank you everyone.